All right. Hello, everybody. We're getting a little bit of a early start tonight, just because I have a lot that I want to cover. And I've got something I think that you guys will really appreciate to show off. So you can kind of get a hint as to what it is on the screen, but we'll sort of go through it here in a minute. Before I jump into all that, I do want to take a quick second and thank a few special people. Those are the supporters of the channel, beginning with the partners. They are Aarsleo, Gerbolis Inc., and Patrick Coleman. They are the highest tier of subscription over on Patreon and YouTube memberships. Everybody else listed under the supporters section are the other tiers of YouTube and Patreon support, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated. I would also like to take a quick second and thank each and every viewer here on Twitch, or whether you're catching it here, whether you're catching it over on YouTube. Without you guys, this project wouldn't exist. So I appreciate each and every one of you coming on and interacting with me, leaving comments on YouTube, whatever it is. I appreciate you guys following along, right? So thank you very much for being here. I would also like to take a quick minute just to thank Thor from Pirate Software for inviting me to the Pirate Crew team here on Twitch. I really appreciate being part of the team. And I just wanted to say thank you for that. For those of you who are not familiar, I will give a shout out actually to Pirate Software. He is another game dev here on Twitch. And let's see. Let me just type here for a second. He's another game dev here on Twitch. He is making a game called Pirate Software. A game called Heartbound, rather. And that game is basically a non-traditional RPG. And it's looking really great. I played the demo, and it's a really great looking game. So I highly recommend that you guys go and check out his channel. He is Pirate Software here on Twitch. So thank you very much, Thor. All right, so with all that said, we actually are looking at something that I kind of whipped up over the weekend, just because somebody kind of asked me in the comments, when are we going to get sound in the engine? And I've been asked that quite a few times, and I finally am like, you know what? Let me just see what I can come up with over the weekend, and that's what I did. Right, and it was really supposed to be a proof of concept, but once I started fleshing it out, it was like, hey, this is this is probably what we're going to wind up rolling with in the production engine. So I still have a few things to figure out. We're not going to go over the architecture of it or anything today, just because it's not quite ready yet. But what I wanted to do is give you guys a quick glimpse as to what is coming. So I'm going to go ahead and pause the music here just for a second. And I'm going to bring up my debugger. And I'm going to run the engine. And this is on a feature branch, FYI. So I'm going to load up a scene here. And you guys will hear audio. And you'll note that the audio goes back and forth between the left side and the right side. And it's actually, what it's actually doing is it's spatially following this cube here. So as that cube moves in relation to where we are, the sound changes, right? And so as I turn around, that changes, right? And so we actually have 3D spatial audio, right? Another way we can look at this is here it gets sort of closer to us and further away, right? And I have the ability also to go ahead and trigger sounds on demand. And these are all being triggered on separate channels, which have different audio levels. And so what that means is that we can actually control different types of sounds with different, what we're going to call audio channels. And so like we can have one for background music, we could have one for environment sounds, one for UI, things of that nature. And so I've got a test script in here that every time I press F on the keyboard, it's playing a sound, but it's playing it on a different channel that all have different volumes. So that's why it sounds like it's getting sort of quieter, right? And so, yeah, I just kind of wanted to show that off real quick. This is not necessarily ready for release yet, but we do actually have audio in the engine now. So what you're hearing is actually in the engine. It's not it's not played sort of in the background, right? So if I back away from this, it gets quieter and quieter, right? Because our source is right here, right? And so I've still got a few issues to figure out with this. There's a few bugs, a little bit of cleanup to do. And then we're going to go over all of the architecture and implementation of this in the next stream. So stay tuned for that, for sure. Okay. So what I have here is I actually have a separate branch for this. And so I've actually pushed up this branch already to the GitHub repo, and I've made a whole bunch of changes to it since that I also need to push. So I'm just going to push those real quick. So you see there I had an initial commit of sound system, added music, enhanced audio streaming, right? Oh, I didn't add first. Right, so let me just get that pushed up. And there's some sample files in there as well, right? We've got some MP3 files and we've got some OGG files. Only OGG is supported at the moment. I am going to be expanding that, but again, we'll talk about that sort of in the future. So if you guys are interested in that, you can go to the repo, and you can easily get to that by going to kohiengine.com. I will drop that link in the chat. And if you head over to down here where it says contribute on GitHub, you can see here that I have the feature audio branch, right? And so if you take a look at that, you can actually pull that and see what that looks like, right? So like I said, it's not quite ready yet, but I figured you guys might appreciate a little preview there. Okay, so with all that done, we're going to go ahead and jump into the UI system. So I'm going to go back to, I think it was just standard UI, right? And I'm going to come over here to testbed main, and I'm going to close all the other buffers. And let's do a buffer clean and a buffer rebuild. What? Debug. Build. There we go. So we've got our debug build going. And I'm just going to go ahead and run again, just to make sure that we're all good. Okay. All right, so we're back to where we were. And what we were working on before was we had the standard UI system. So I'm going to open the header file for that and the implementation file for that. And if I go back to the header, last time we left off, we were implementing this SUI control. So this is sort of the base control that doesn't really have any functionality of it on its own, but all of our standard UI controls are going to be based off of this guy, right? So they'll just implement these essentially a little bit differently. And then from there, we can go ahead and implement the logic for each one of those. So I'm going to go back to the roadmap. I think the first thing that we were going to do was the panel, if I remember correctly. So a panel is basically just a just a flat space on the screen that's typically of a solid color, right? And I think that's probably the way that I'm going to do this. Is just I'll probably just render a quad as a solid color, right? Or maybe even a semi-solid color. So I think, let's see. We have the base control, create, destroy, load, and unload. Did we actually... I think we implemented those as dummy functions. Yes, we did. Okay. So let's go ahead and do now the panel. Right? And we're basically just going to take these 6 functions. And we're going to rename them to SUI panel. Panel, base control. Right? And these are essentially going to take in these the same type of structure, right? And that's how we're going to sort of build these things out. So what we'll do is we'll grab these guys and grab these guys and go into the C file, and we'll go to the bottom here and implement these. And one thing that we could do, if we wanted to sort of take a slight inheritance approach, if you wanted to call it that, is we could essentially call these base functions, right, first. We could call these guys first, and then if they happen to fail, we could boot right out of them, right? That might be an easier way to do this, or maybe a standard way. I don't know if we want to standardize on that. I haven't really decided yet. But for now, I think that's what I'm going to do. Instead of duplicating this logic, right? We already have it here, so we could just call it from here. Timon, how's it going? Welcome. So if not, SUI base control create, right? And then we'll just pass name control. Out control. Return false. Otherwise, return true. Right? We'll just sort of repeat that pattern throughout. So let's see. We'll want that for load, update, and render. And I think these other ones, this is just going to be load, self. This is going to be updates, self. And this is going to be render, self. Right? Oh. These also need p frame data. So, oh, hey, sidecode, welcome. The reason I'm not returning that is because I only want to boot out here on a failure, right? because all this is basically doing is just this logic, right? So if this is true, I don't want to just return true there. Otherwise, I wouldn't bother even writing this, right? I just update the function pointer to go to it instead. What I'm doing here is I'm basically just reusing the validation logic in this sort of base function here. And if that fails, then I return, right? But in this case, I don't want to fail if I'm successful because I'm going to do other stuff here, right? Hope that makes sense. Okay, so in, let's see, base control create, instead of doing this, in fact, let's see, I probably don't want to call the base control on this one. I guess I can reassign it, it's not a big deal. Here, right? And this is essentially going to be instead, we have destroy, so it's going to be panel again. All right. Oh, why did it insert the whole thing? I didn't want it to do that. That's annoying. All right. Anyway. So we assign our function pointers on create, and I think on create, that's all we're really going to do. We're not going to worry about standing up any geometry here. We'll do that in load. The other thing that we're going to need for panels is some sort of configuration. Or I guess some way to set size, right? So we're actually going to need, I guess we could just assume a default size for right now. We also need some sort of internal data. So let's type def structure. We'll call this SUI panel internal data. SUI panel internal data. Right. And this is basically going to be a, yeah, I think we can just go with a size on this one. Should I go with a rectangle? Let's go with a vector for rectangle, right? So that'll give us the X, Y, the width, and the height on that. And then we're also going to need struct, actually, geometry, right? Which means that we need include resources, resource types. That'll give us our geometry. I don't think we're going to bother texturing this, right? Because we're going to have an image box if we want some sort of texture on there. So the only thing, other thing we need is a vec for color. I think that's all we're going to need. So in this case, in this case, I think we're going to go ahead and do a out control internal data equals k allocate size of SUI panel internal data and memory tag. Do we have a UI? I don't think we do. What else can we use in here? I don't really want to tag this under the renderer. guess I could just tag it under... I'll tag it under renderer for right now. Right, so that'll give us our internal data to go ahead and fill out. Just add UI. Yeah, I guess I could just add UI. I'm just not 100% sure that I want to go with UI, right? Because UI systems are sort of external to the engine. Kind of. Like standard UI is like its own thing. I guess I could still call it UI. I don't know. I'm not sold on it yet. Updated it here, so I also need to update my string table. So I'll just call this UI, I guess. Good enough. Next time after you select the text, you want to replace use C instead of D. That way you get the next line and hit dot, it will work. Oh, are you talking about the column select thing? I'm still not used to really doing that in Vim yet. So like if I want to do I think my IntelliSense is what's doing it. Or my my auto completion. If I deselect that, maybe. Oh, I think I have to hit escape, not enter. Maybe that's it. I can't remember. That was it. I have to hit escape, not enter. That's what I'm doing wrong. Okay. NeoVim noob. Cool. Thank you for that. Appreciate it. All right. So we have our internal data. We're going to define some basic sizes or some basic like defaults in here. So we'll say SUI panel internal data typed data equals out control internal data. And then typed data rect equals vec4 create. We're going to go with, I guess, 0, 0, and 10 and 10, right? We'll go with a 10 by 10 rectangle. I need math types. Actually, I think I'm going to need kmath in here. So I'm just going to include that. All right, so that's the rectangle. The default color equals vec4 1, which is basically going to give us white. And then the geometry I'm going to hold off on until load, just so that we have some reasonable defaults. And we'll create some functions to update those later. Okay, so destroy. I don't think the sub destroy does. Oh, yes, it does. It destroys the name. Okay. All right, so SUI base control destroy self. And then, oh, does that zero the entire thing though? Okay, so I should probably do that last. So we'll say if self internal data. Ah, wait a minute. You know what, though? I should probably add that to the base destroy. Let's do one more thing. So we have our internal data. I'm also going to save off internal data size. That way we can generically destroy it from the base function. So we can say out control internal data size equals size of SUI panel internal data. And I guess technically speaking, we can out control internal data size. And then up here in destroy, we can do the name. And then if self internal data and self internal data size. Okay, free self internal data self internal data size memory tag UI. Okay, so that takes care of that for us. We'll obviously have some other things in here in destroy besides just that, but that takes care of the internal data always. All right. So load. We're going to need to load up some geometry. Which I'm actually going to steal some code from testbed main, because we actually kind of have some of what we need in here. I just don't remember exactly where it was. Where do we create that? Here it is. So some test UI geometry, which this is basically a plane, which is exactly what we need. I mean, technically we're generating texture coordinates and all that stuff, which we don't really have to do, but I'm going to do it anyways because it's in the data. Geometry config. Here's the vertex data. Here's the index data. Acquire from config. Okay, so this is, I'm basically just going to copy this whole thing, because this is essentially what we need to do. All right, which we probably ought to come up with. We probably ought to write like a helper method to do some of this stuff for us. What you were talking about was not for the column select, though. Oh, okay. What were you talking about, out of curiosity? Let's see. I need to go to include systems geometry system. That'll give us this. Create a simple plane. All right, so we're using vertex 3Ds, which is good. That's what we want. We don't want any sort of material, though. So I'm actually going to wind up rendering this a little bit differently. So I don't want a material. The name. It's going to wind up being... Oops. This. Self.name. Nope, we got ads. Just going to pause real quick for ads. Just realized I never turned the music back on. Got about 10 seconds left on ads. Alrighty, so really quickly, just to cover the question there about the ads. So ads don't always show in every region or area, but basically there's scheduled ad breaks that come up for Twitch. And for anybody that's not subscribed, or if you happen to be in a certain region, you'll get ads, right, for a minute and a half. So what I do to make sure that nobody misses content in the stream as I'm streaming is I pause the stream for a minute and a half during ads, right? So there's a possibility that you might not be seeing ads, but a lot of the other viewers probably are, right? So I like to pause the stream for ads. So what you're talking about is you want to replace the word with place. If you select it and hit the word C, write down place, then go somewhere else in your code and write another word and hit dot, it will automatically replace it for you. Yeah, so the dot is the repeat. I use that quite often. Yeah. It repeats the last action, basically, which is pretty sweet. I do use that quite a lot. Okay, so we're going to go ahead and take the name. We are going to stick with vertex 2Ds for now, I think. All right, so this is all putting into the testbed state, which we don't have here, so we actually need to store the geometry itself. I think the geometry is here. Is that an array of pointers? It is. Yeah, because I think this actually returns a pointer to geometry. So in our internal data, we're going to need to change that to a pointer to geometry. But use D after you select the text, not C. Pay attention to details. Well, it depends on what I'm doing. Try it with both and see the difference. Yeah. I will next time I run into that. So you're saying... Well, actually, what I tend to do is a lot of times, like, I'll do change word, right? But I think what you're talking about is basically just doing this, and then change, right? And then something, And then you could just do it over and over again, right? Is that that's what you're essentially talking about? Okay. So we actually probably do want to generate a unique ID for all of these things. We should probably actually be doing that at the control level. That way, if we do want to use our pixel perfect picking shader, we can actually do that. So I'm going to go ahead and let me open up it's here, I think. So I guess for here, I'll put U32 unique ID. And we're actually going to move this functionality up to Snake Wiz. Thank you so much for the follow. I appreciate it. Welcome. Let's see. Base control create. Here we go. We'll do it here. Let's actually move this down here. And out control. Unique ID. We need... I think that was under core. Identifier. Yeah. So we'll go ahead and get that. And then we're just going to set that to out control. And then when we destroy, we'll also have to release that. So we'll say identifier release ID self dot unique ID. That way, each one of these things automatically gets a unique ID. Right? So the next step of this, we have this done. Geometry count is only ever going to be 1, so we're not going to treat this like a mesh. We don't need to do that. We do need... Do we have the casted state? I don't think we do. Let's go ahead and grab the type data. I'll put it here. And we can say type data geometry is equal to that. Transform. We're going to get that from the base mesh itself, so that's fine. Generation. I don't think I'm going to worry about generation. So I think that's actually all we need to do in terms of setting it up, and then we just need to go ahead and unload that, right? So, let's see. Over here. This was initialized. I don't remember if we actually had to do anything else with it beyond that. I don't think so. I don't think we did. I think that was it. Okay. Let's actually have... You know, this is one of those... Somebody asked me the other day, how do I remember all the code I wrote? And I don't. So let's have a look with this. Acquire from config. Registers and acquires it. I don't think, though... I don't think this updates that. Or uploads it, rather. Registered geometries. Oh, I think create geometry actually does. Render geometry create. Okay, so it does upload it to the GPU. All right, that's what I needed to know. Okay. Note this uploads to GPU. All right. So at that point, it's loaded. In which case, we can actually go ahead and render it, right? So by the time this comes back, we should be good to go ahead and render it. So down here, I actually need the typed state again. Oops. This should be self. All right. So typed data G, if that exists. Then we can do the thing. Otherwise, we're just going to skip it. And I don't think we really need to return false on there. We can just say, hey, it's done, whatever. I think we're only going to return false on like an error. Now, this is where it gets a little bit tricky, because the way that the UI stuff works currently is a little bit weird. So essentially our UI passes us into a UI shader, which currently takes a material, which I don't think is actually something we should be doing. Because not every UI object's going to have a material. This one, for example, doesn't. So to your point about the ads, I've seen plenty of streamers do it. One of them that does it is Pirate Software, right? And he's got, what, 40K, some odd viewers, right? That's actually where I got the idea from. I've seen several development streams that do it, right? Because for those people that can't afford to purchase, a sub, but that do get ads, it kind of sucks for them to not be able to hear what I'm saying and just be able to see that little tiny thing of code on the screen, right? So, do laptops need UPS or only desktops? You mean like uninterruptible power supply? Is that what you mean? I mean, a laptop kind of has that built in with a battery. I say viewers, I meant followers. Hold on a second. Twitch. Yeah, he's got 36K followers. So he's not doing too bad for himself. Yeah, I just figure, it's something that I try to do to prevent people from missing content, right? If I see that my numbers drop because of that, I'll do something about it, but yeah. He generally has about 500 viewers at a time. So, anyway, all right, so we need to go to the front end, because I think the front end is should be good for us to actually draw our geometry. I think all I need is geometry render data for that. So I can fill out some geometry render data. Render data, unique ID is self, unique ID. Render data, geometry equals self dot, type data dot g, render data. Winding inverted we don't have to worry about. Model is going to wind up being, for now, transform world get. Self X form. We also are going to need include math transform. I think this needs the address of that. Yeah. Okay. So there's our render data. We're also going to need include renderer front end. And we'll say renderer geometry draw. And we will pass through that. I think that returns a Boolean too. Nope, returns void. Okay. All right, so there's our render data. And this is probably not the way I'm going to do it. Let me think about this for a second. Because this allows me to just call render directly from the render pass, which might actually be nice. And then I can just set uniforms before this. That's probably the way I'm going to do it. Okay. So, I want to take a look at our shaders really quickly, because we have the UI shader. Actually, I'm going to look at the UI shader config. Let's see, we have vertex and fragments, imposition, text coordinate, projection, view, properties, which is a struct of, I'm thinking, material properties. Diffuse texture, which we also don't need, and model. So I think I'm going to have to actually write potentially a different shader for this. So I'm thinking probably it's going to be a super simple shader that's just a color 2D shader. So let's call this shader dot standard UI shader config. Okay, so shader standard UI is the name. Render pass. I don't even think we're parsing this anymore. We're using it. I'm going to delete that. Okay, so these are going to be standard UI shader. We did away with the built-in. Standard UI shader frag invert. We want in position, and I suppose we could take texture coordinate for now, since that's part of the vector 2 structure, or the vertex 2 structure. Projection view stay. Properties, we'll have to see what that is. We don't need this diffuse texture, but we do need the model matrix. Okay. So I'm going to base my shaders off of these guys. Let's do an add. This is the fragment shader, so I'll say standard UI shader dot frag dot glsl. And out color is fine. UI properties diffuse color. We want that. Okay, that's scope 1, so that makes sense. We don't need samplers. And actually, we don't need this DTO either. So actually, literally all we're going to do is just output the diffuse color. So, that looks pretty good. Let's go ahead and take a look at the vertex shader, which I think is super simple. I suppose I could just technically use it like it is, but I'm going to create a copy anyways, just in case one of them changes. So we're going to add standard UI shader dot vert dot glsl. So we need in position. We'll take in text chord. I don't think we're going to do anything with it. Global uniform object is projection and view. Push constants only has the model matrix in it. We don't need the mode, so we're not going to support that here. The DTO of text chord, we're not actually going to do anything with that. We deleted that from the other side. We can actually do away with this because we're not doing anything with the texture coordinate. And there we go. All right, so I think that's all we should need to do to create that shader. That should give us everything we need. And the question is, where do I want to actually use this? I think it's probably going to wind up being in the UI pass is what I'm thinking. So this is where we're loading the standard UI shader, so I think it makes sense for us to load our new shader here as well. I'll call this SUI shader. We probably ought to have like a different render pass for this, actually. But for now, I'm going to kind of include them because we might actually just wind up replacing this, all of this content with the shaders that we're using here. So UiPath creates, that should be fine. Right, we need locations as well. So UI shader locations. Let's type def a new struct. So UI SUI shader locations. And we're actually going to have most of these things. Except we're not going to have a diffuse map. And then down here, SUI shader locations, SUI locations. Group those together. So we'll say load the standard UI shader. So this one's going to be shader.standardUI. SUI shader name, SUI config resource. All right, so that's the resource loading. And then here's the configuration that is parsed from that. SUI config resource data. Okay. We are still going to assume it's the first pass, since that's all we have. So we got that. Oops, this config needs to be SUI config. And SUI config resource, we want to release that. So this is going to be SUI shader. SUI shader name. So I think I can just say SUI locations. Diffuse map I don't need. Oh, but I need the other ones. Yeah, I need the other ones. So that's going to wind up being... see, we have projection. View. So we had projection, view, properties, and model. I think that's... yeah, that's it. Okay, cool. Totem Falico, welcome. First time here. Also recently started following the Vulkan SDK Triangle tutorial. Hope to develop my own engine one day. How is it going? Well, awesome. Welcome, first off. It's going pretty good here. We are in the middle of sort of finally building out our UI system. And I'm just kind of refactoring some old stuff that we did a long time ago that was really meant to just be kind of temporary stuff to make it actually a little bit more flexible. So that's kind of what we're in the middle of now. Earlier in the stream, I did actually also demo some audio support that I've been working on sort of over the weekend. I kind of just banged one out real quick. And so we've added that to the engine, although not officially yet because it's still kind of in a feature branch. But yeah, it's coming along pretty good. I'm happy so far. How about you? How are you doing? I need to make these pull from the right shader. Shader. Okay, we should be good to go there. So we have the shader loaded, all of its uniforms loaded, or its uniform locations, so that we can go ahead and apply those things. So the only thing I'm trying to think of is if we want to control the rendering from here, we don't have this information here. So either I could pass it, which is kind of terrible, or I could extract the properties from this and use it here. And I'm trying to think of which one would be better, or if there's some sort of hybrid solution that we could use instead. Because what I don't want to wind up with is like a bunch of getters and passing data around. That gets sloppy really quick, right? We want something to just say, set this uniform to this, set this uniform to this, and be done with it. And realistically, like projection and view, those are set by sort of the current screen we're on, so I don't have to really worry about those two. What I really have to worry about is properties and model. Which model I can get... I guess I could get the geometry render data, right? And then perform this draw call over here. But then that kind of defeats the purpose of having render. I'm going to think about that for a second. Reference it with a pointer. So part of the problem is these locations themselves are internal to this file only, right? They're actually, like this structure is actually typedef in the C file to keep it private. So I don't want to necessarily like go passing around shader locations because that's kind of lame. It's just something I hadn't thought of in advance. You had to put it on pause for a couple of weeks because learning C++ and Vulkan plus a new day job aren't exactly a good mix. Ouch. Yeah, I could definitely understand that. So wait, you're learning C++ and Vulkan at the same time? Godspeed, my friend. Guitar player, welcome, first time chatter. Welcome to the stream. I love the channel project itself, and I think you're super smart and cool. I don't know about all that. I'm a huge dork, and I don't know about super smart either, but thank you. Why do I use Vim? Isn't VS Code of my taste? Cheers from Argentina. Well, welcome from Argentina. I actually, up until, I don't know, a few months ago, I actually did use VS Code, but I kind of started using Vim at my work every day, and I really like navigating it and the way that it works and the motions and all that. It makes me, in general, a lot faster at editing code than I can do in VS Code. So I use it as my editor, but I still do use, for right now anyway, I still do use this to actually debug. right? So I use that to actually run. I can do it in Vim, and I actually do that sometimes, but if I'm having to debug something kind of complicated, I do use VS Code for that. Yeah, I've been a dev for like 10 years at this point, but only Java, PHP, TypeScript, JavaScript, Bash, Python, Swift, and a little bit of R. Nothing in the C family, but you'll push through. Yeah, you will. Learning your first language is always the hardest. Learning everything else just kind of builds on top of that, right? It's just remembering syntax rules, basically, and learning whatever libraries go with it if you want to use them. But I mean, if you are familiar with Java and PHP and TypeScript, like those are realistically somewhat kind of close, right? But like the big difference, memory management. Memory management actually isn't that complicated. Like pointers are actually a really simple thing, right? It's just you have to remember to free them when you create them, right? And that's one of the reasons I usually tell people they might be better off learning C first and then jumping to C++, because C is a much simpler language. It doesn't have all the complex crap that C++ does, and it forces you to actually use memory management techniques and think about it in such a way where when you make the jump to C++, you're like, oh, this is easy now, right? But yeah, I mean, once you get used to it, like I personally prefer writing in C or C++ all the time, because I don't like stuff managing my memory anymore, especially when it comes to game. So C is such a beautiful language. Yeah, I mean, it has its issues too, for sure. But I mean, you know, how many things in C are undefined behavior, right? That's annoying. But yeah, and its simplicity, it's a really awesome language, and that's why I'm using it over C++. Okay, so in lieu of having a render, because that's not really the pattern much else follows, I could have this push to a data structure that contains all the data that it would need to be rendered, and then have this guy pick up that data structure. And that data structure might be something like a tree, so that you can have elements nested within one another, right? And that would still give us the rendering order that we need, which would be another problem of not doing it this way, right? Because this is recursive. Although you wouldn't know it from here, because I actually didn't put that in, but yeah, that's a thing. So the render calls on this are going to be recursive, just so that they follow through a tree and everything renders in the right order, because we're not going to be using a depth buffer for the UI, the standard UI. So everything's going to appear on the screen in the order we draw it, one on top of another, right? So if I created a structure that basically this render outputs to, and that structure is then fed over to this, it would theoretically have what it needs to do the thing. But the structure would have to be... it would have to be extensible enough so that this could read it and understand what it needs to do. For example, we might have objects like this, like our panel, right, that just displays in a color. But then we might also have other things that need textures or parts of textures. I might stray away from actually using multiple textures on these things just to keep it simple. Actually, that kind of brings up a point. My brain is going in about 1,000 different ways right now and of how I could implement this. And the more I think on it, the more that I'm thinking that the tree idea might be the right way to go. Let me catch up on chat here. Pointers are the single most powerful idea I've ever seen in a programming language, but I can't deal with C anymore. I can't deal with Java's BS anymore. I feel you on that. Honestly thought that since my engine will probably be 2D, with a little bit of fake depth, like an Ori of the Blind Forest or Hollow Knight. Yep, okay. I saw that there are Vulkan wrappers in Python. There's lots of Vulkan wrappers out there nowadays. Seriously considering that with some external libraries to boost graphical processing and avoiding being bottlenecked by Python's single GIL. Trying to think of what that stands for. Ads, you're right. And for those of you that don't see ads, this is why I break, because some of you do get ads. Yeah, so the timer from Twitch is telling me another 30 seconds. I'm wondering if the timers are just off today. Does anybody actually see ads at the moment? Well, actually, you're not going to be able to hear me if you do have ads up on the screen, so never mind. It's only got 15 seconds. Yeah, so the ads I know vary by what device you're on, what platform you're on, what region you're in, a whole bunch of things like that. So like some people might get one ad, some people might get the full 90 seconds of ads. So I'm not really sure about that, but I think that the timer that they give me is supposed to account for the whole thing, for all of the possibilities. Let's see. You should isolate the structure and put it in a library so you can access it from anywhere in the code. So what we're doing right now is the standard UI is actually a library of itself. It's separate from the engine. It's an extension to the engine, basically. And this UI pass right now is part of the testbed application. That's sort of the driving executable that we configure and use all of these different plugins and stuff. So right now that exists here, but it's probably going to wind up moving over here to the standard UI system. It'll have its own sort of pass that gets utilized for that. So they'll be aware of each other. So that is not really an issue. Hey, Trash Can, how's it going? Good to see you again. Let's see. While watching Travis, I more and more tend to just use a pre-built engine. Yeah, I mean, here's the other thing too, is like, if you're not ready to sort of bite off the chunk of rolling everything yourself as I'm doing here, you can always use something like SDL, right? In fact, I have a little side project here that might be utilizing SDL. Maybe. Right? Where's the... Right. I have a little side thing that I'm working on here that's using it. But I'm probably going to wind up actually converting that to use Kohi. But anyway. Let's see. Initially followed coding alongside, but not really learning. That is not really learning. I could just, well, watch them solely. Yeah, fair enough. I mean, it's less of a tutorial these days and just kind of more showing the thought process behind making some of these design decisions and stuff like that, right? Can I not hear you? Hamster Dev, I don't think I can hear you. I can see what you're typing, though. Nope, no ads. Okay. Global interpreter lock. Okay, that's the GIL. You only have one real thread managing the script. You don't have true multi-threading because even multiprocess runs on a single mutex. That's like JavaScript then. Yeah, not a fan. Ads are cool and all, but what about lads? So, yeah, the joke there is, and I'll bring up the ads screen for a second so that you guys can see it. Whenever I type in for commercial break ads, I type in ! ads, right? Which gives us this breaking for ads so nobody misses any content, right? And somebody pointed out in chat that looks like lads, that they were reading that as lads because it was like blurry. And so that's why I put the little meme in there for lads. That's what that's all about. I'm doing pretty good. Thank you for asking. Been recently reading a DirectX 12 book that also goes over the math. Nice. What book is it? Is it good? It's been breaking your mind these days? Yeah, nice. DirectX 12 is something we're going to be tackling on this channel for sure with this engine at some point. I just want to get it relatively feature complete before I do that. Oh, that was just because you said when people have ads, they can't hear you. Yeah, if they actually have ads on the screen, they can't. Frank Luna's book. Introduction to Game Programming with DirectX 12. Is that it? This guy. I didn't recommend this one. I recommended Game Engine Architecture by Jason Gregory. Oh, Taman did. Okay. Okay. How did I manage to get self-banned from my own Flask app? That's a good question. I see what you mean. Okay. All right, cool. Yeah, so maybe I'll take a look at that book if it's any good. Because I haven't actually done anything in DirectX 12 yet. I've done DirectX 11, but not 12. Game Engine Architecture by Jason Gregory. Yep. It's a fantastic book. In fact, is it here? And as you can see, I've got lots of bookmarks in it, or things that aren't really bookmarks, but are being used as bookmarks. Yeah, it's a fantastic book. I reference it all the time. Get in there. Close enough. All right. Oh, it's a chunker. Yeah, for sure. It's definitely you could use it as a weapon if you wanted to. It's definitely heavy. Okay, so we could theoretically... No, I don't want to add that to frame data. That's lame. All right, let's swap this out a bit. I know I said we weren't going to use a texture, but I'm thinking we are going to use a texture for all of our UI elements, because let me see if I can find a graphical example of it, because I don't have one actually created, but let me see. Let me see if I can find an example of what I'm thinking of. So basically what I'm thinking of is using sort of like a sprite map almost for all of our little UI controls. And I'm hoping I can actually find an image that kind of looks like what I'm going for, but I'm not finding one. It's basically a texture atlas, right? Here we go. This will work as an example. So this is just a random example I found, right? But this will kind of give the idea of what I'm talking about. So we've got some 9 slices here. I don't know why they have so many different varieties of them, but we have some 9 slices, some buttons, some random controls, bars, things like that. And so what we're going to do is, probably create an image like this. And I'm thinking even for the panel, maybe we just have a small section of the image that's a white texture that we sample. Even if it's only like 1 pixel that we sample, it doesn't really matter, right? But we could basically bind one texture and draw all of our UI elements using that one texture, because the texture would contain all of the little buttons, the little corners, the little, everything that we would need, right? And so the more I think about it, I'm thinking that probably is going to be the way to go. So we may actually want to go ahead and use, actually use a diffuse map on that. Oh, you bought the book? Nice. So far you're liking DirectX 12 better than Vulkan? I can't say I'm surprised. Vulkan is a very verbose library, although I've heard DirectX 12 isn't much better, but less typing to some degree. You mean you don't have S types that are like this far that go across the screen? I mean, I get why they did it, but you know what? Yeah, let's modify this. The fragment shader is really what's going to need it, right? So, I'm actually going to. Actually, it's both textures, right? Or both. Let's go to this guy. Right, so we are still going to use the diffuse color, which will basically be a tint. And then we have samplers, which we're only going to use one of those. We're not ever going to have more than one, I don't think. We do need to transfer the texture coordinates over from the vertex shader. So, yeah, I'm actually going to put the texture stuff back. And I realize that this duplicates basically exactly what we had for built-in UI shader, but built-in UI shader is going to be going away at some point. So we want this one. Right. And then we want the built-in UI shader config, which actually is going to wind up looking exactly the same for right now as well. Okay. So I guess we'll go to UI pass, which makes these the same for right now, and that's kind of lame, but just in case we diverge, I want them to remain separate. So SUI locations, let's go ahead and add diffuse texture, and I think we called that just diffuse, I think. Let's see, where was that? Here. Samplers. Totem, thank you so much for the follow. I appreciate that. Automod does really hate you. Oh, pff, I don't care about that one. It's like super sensitive. I keep allowing things, but yeah, it's still kind of new, so. The only thing you don't really like about DirectX is built in a COM architecture, so there's a bunch of unnecessary allocations everywhere. Ooh. Does it allow you to pass an allocator to handle those? Because if not, that's gross. Vulkan's debug layer seems miles ahead of DirectX, basically. Which, that doesn't actually surprise me. The Vulkan debug layers are actually pretty decent. Take BG3, the Vulkan version crashes quite often where DirectX 11, 12 are stable. Well, yeah, but I mean you can program it to like not crash. Right? Like that's literally the application's fault if it's crashing. It's not Vulkan's fault. It's probably just the developers are more familiar with DirectX than they are Vulkan. I don't think ComPointer accepts a custom allocator. Yeah, I don't know how it works under the scene, but yeah, that would be really unfortunate if you can't control the allocations there. Super unfortunate. Okay. So I think in the shader config, we called it diffuse texture. Okay. Is it not diffuse texture? Or is it just diffuse here? Why are you bleating? Didn't I just... I thought I added it. Apparently I didn't. Let's diffuse map. Okay. Yeah. I like the image array idea. Just using a texture atlas. I think that's really going to work. So I'm probably going to have to make one of those images offline because I don't think doing that on stream really makes sense. But I think that's the way we're going to roll because that way everything uses the same image. We can bind the image once and be done with it. And just basically pass a whole bunch of quads with texture coordinates and draw them. Which technically means we could batch all that crap too. Yeah, Vulkan kind of is the only alternative to DirectX 12. Because, I mean, you could say OpenGL is, but it's not going to give you the latest, greatest, ray tracing and stuff. You're not going to get that from it. I was just thinking Metal, but I feel like there's things that Metal can't do that Vulkan can. And that's one thing I'm going to have to bite the bullet on eventually, too, is a Metal backend. If the creators of OpenGL made Vulkan, there must be a reason. Oh, yeah, there's a reason. The amount of deprecated API. Absolutely, there's a reason. Not to mention all of the hidden state and crap that goes on in the driver that the driver is responsible for in OpenGL that it really shouldn't be. Oh, you mean Metal 2 for working on PC, not only Mac? Yeah, that's never gonna happen. Have I ever coded in Mantle? No. I thought about it, but it didn't really take off. Which is kind of what Vulkan's based on anyway. So yeah, oh, you're doing the, Totem, you're doing the Vulkan on Mac? Yeah, so it works decently well. I've hit a couple of issues with like extensions not working and having to work around that, but it hasn't really been too terrible. All right, so geometries have something in them that is probably not great. So geometries have, you know, your typical ID stuff, your center, your extents, your vertex data, your index data, all that, which is good. They also include a material, which is convenient, but not always what we want. So currently the way that the UI controls work is we actually have just a UI material type, which is nothing but a fancy wrapper around a shader anyway. So I think probably what I'm going to do is for our geometries for the UI, I'm just going to ignore material and not use it. And instead, just bind everything manually in terms of the uniforms. The issue with Vulkan is not Vulkan itself, it's NVIDIA ignoring the damn specification. Yeah. The problem is that on Mac, Vulkan uses normal GPUs in here. It's an M1 Mac, so no discrete normal GPUs in here. Yeah, but I mean, I have an M1 Mac and it works fine on that. When AMD driver enforces you to follow the spec, it crashes. Yeah, I'm going to have to pick up an AMD card too, because I've already got a couple of bugs reported that I can't actually troubleshoot because I don't have an AMD card. Super annoying. But those issues exist with OpenGL as well. One thing I'm absolutely confused about is if RTX is a dedicated lighting engine swap chain or if it's just an API to call when you're initializing the code. I have not done ray tracing using RTX stuff, so I can't tell you. That's one thing I plan on researching, but I haven't gotten there yet. Yeah, and then people blame Vulkan because AMD drivers crash. Yep. What dictates what is allowed or not is the driver. Yep. Which can get really annoying sometimes, but at least they give you a way to query it. Whereas in OpenGL, you kind of had to sometimes be like, well, if it's this type of card, don't use this feature. But you had to like parse strings and crap to actually figure out how to do that. It's gross. If you build on an NVIDIA and ignore layout transitions, the driver will be okay with that. As soon as you run that on an AMD card, crash. That's interesting. I don't feel like I've done that yet, but how do you keep yourself from burning out? I have a big project currently, I'm kind of the only one doing it, and I procrastinate. I procrastinate all the time. All the time. Totem, AutoMod really does hate you. but I'll allow it. How do I keep myself from burning out? When I need breaks, I take them. And sometimes it means I come back and, you know, I hit the ground running and am more productive than ever. You know, there'll be times where I won't touch this code base outside of streaming, or sometimes I'll even take a break from streaming because I'm just like, you know what, I can't do it today. And that's okay. It does happen. In Vulkan, you can query everything at startup. So you either messed up the driver or the driver is garbage, or both. Yeah, so that is a nice thing about Vulkan, is that you can query what it supports and what it doesn't. Add totem, don't worry about it. I don't care about it too much in chat, as long as you're not, you know, like harassing anybody or anything like that. But yeah, I don't care about it in chat. I don't do it on stream, but that doesn't mean you guys can't. Some things are not capabilities. It's internal implementation. Yes, absolutely. And some of those capabilities are some of the most annoying things ever to get around. All right. So what I'm thinking is the structure should be a bunch of these render datas, right? But it can't be render data by itself because it's going to have to include more than that, right? So this gives me the geometry in the model. I guess I could put the texture sort of at the top of that tree. What else do we need? So the view, actually it might just include that. Actually, what is the UI shader even doing with these properties? Is that the... Oh, that's the diffuse color. That's why. Okay, we do need that. Okay. So let's go to... Let's go to the header file and let's kind of take a look at what this structure might look like. So there's a couple things we need. We probably ought to... Our render interface is here, so we probably ought to put it here. Actually, I think this is literally just going to contain a linked list of render data. I think a linked list will literally be enough. Or actually, we don't even need a linked list. It could be a flat array. D-array. With just a few properties at the top. Okay, so let's say standard UI render data. And at the top, we will have a texture map pointer that we'll call UI atlas. And then we'll have a D-array. Oops. A D-array of geometry render data. And this will be... Do I want to call it objects? Renderables, I guess. I don't know. So that'll contain a count and the actual renderables themselves. And then the UI atlas that we're going to draw with. And it could also contain other top-level data like mat for projection, mat for view. The only thing out of here we're actually missing then, because we have this, we have this, we have this, and this. The only thing we're missing is the properties. Which in this case is literally just the diffuse color. So I suppose we could wrap this D-array with that, because I don't think geometry render data actually has a diffuse color in it. Nope. I mean, I suppose I could add it. I don't know if I'd like that, though. Because most, like, world geometry is not going to use this. You have a lot of overhead with NVIDIA compared to AMD. Overhead in terms of runtime overhead, or like writing code overhead? Oh, CPU overhead. That's not surprising. One thing that why will it literally not let me? NeoVim, what are you doing? Why are you being a bananas? Alright, that is really annoying, this pop-up window won't go away. Oh, I closed the buffer behind it. Sweet. Alright, you know what? Oh, now it leaves. Okay. So I guess let's go. I guess we're gonna have to wrap that in another structure, which is kind of annoying. I guess we'll call this a renderable, right? And literally all this is going to be is geometry, render data. Render data. And then diffuse color. And this will wind up being standard UI renderable. So I'll have to go 2 levels deep to get that, but I think I'm okay with that. So basically, at this point, we won't even really need a tree, right? We'll just pass a pointer to this guy in and add to this. Because we're going to go through the list of all of the controls in order, we can literally just keep tacking them on to the end. And then once we have this all built, all we literally have to do is loop through these and set all the uniforms, and we'll be good. Set the uniforms and make the draw call. Oddly enough, the AMD drivers are better in general, especially after you give it those 3 years to hone it down. You have a Vega 64. We went from a 1070 over to a 1080 in performance just from driver updates. Wow. NVIDIA burns money to have companies optimize their code to use NVIDIA cards better than AMD cards. So, I haven't had an AMD card since shortly after they became AMD from ATI. And I know back in the day their drivers used to be really, really crappy. I guess that's not the case anymore, from the sounds of it. Yeah, I mean, the thing is, like, the graphics card I have is not going to be obsolete for a while, so I can't, like, justify that. The time ATI still existed, I didn't even know how to use a computer. Yeah, I just dated myself there, I know. Ever since Ryzen and the Vega 64, they got their stuff together. Okay. Yeah. ATI, like, I remember ATI used to be, like, their hardware was top tier back in the day, but their drivers were absolute rubbish. 92% taxes, what? I mean, rest assured, when I do release a game, because this was something that I actually learned from Pirate Software, I'll be releasing the first game that I make with this at localized prices for sure. Because I do know for, Brazil, the equivalent of a $60 game just doesn't make sense. So, yeah. I am aware that that's an issue for sure. Basically 92% taxes for stuff bought from AliExpress and stuff. Holy crap. That is intense. And terrible. Ooh, you know what the best part of this is going to be? Is we can actually use the frame data allocator to do it. So we don't even have to reach out to like our system dynamic allocator. We can actually use our really fast linear allocator to set this up. And it just automatically gets thrown away at the end of the frame. So that's actually kind of sweet. All right, so Exxon47, welcome, first off. I've heard that Brazil has absolutely awful import taxes. Apparently so. Yeah, I didn't know it was that high, though. Jeez. That's got to be like the craziest import taxes I've ever heard, I think. I will never complain about import tax ever again. Okay, so let's say standard UI render data. And we're just going to call this render data. Right? So we actually just need to put that. Let's see, system UI render. I guess at this time we can stand it up here and pass it down, so we don't need to put it there. We do need to put it standard UI render data. And we'll put it there as well. And Why have you done this, Vim? Why have you done this? All right, so standard UI render data. And then also the base one's going to need it right here. Standard UI render data. And update active. Here's the render. So this is what calls render on everything. Okay. So, oh, you know what? Since this is recursively called, I do have to add it here. So, standard UI render data. And then we have render data and render data and this guy needs it too. Standard UI render data. Okay. So that gets passed all the way through. And then here, here's where we would actually fill that out. So we create the geometry render data. Then we create a standard UI renderable. And actually, let's do this. Renderable.render data. Right, we'll just basically fill out the structure and then renderable.diffuse color. For now, we're just going to do we have? We don't actually have that. Okay. So for now, we're just going to use white and say to do pull from object properties. Right? We're going to get rid of that draw call and instead say render data. I think we need D-array. Or do we already have it? Nope, we need it. Include containers D-array. Alright, so D-array push. Oops. So render data is going to be pushed into, or no, render data dot renderables is going to have renderable added to it. There. Okay. So essentially our render function essentially just prepares a renderable or set of renderables and adds it. And that should give us everything that we need. The only place that's going to get a little bit weirder than this is there are going to be some instances where we may need to override the texture. So we'll have to deal with that when we get there. I'm thinking viewport controls for that, but we might handle that differently. We'll see. Wait, you got ads now? Oh, did I miss an ad break? I might have. I might have actually missed it. Is this a tiling window manager? No. I'm using Cinnamon right now, but I do have. I do also have what the heck is it called? Hyperland installed. But I had to stop kind of using it because it's using Wayland, and Wayland doesn't support things like RenderDoc, so I can't use it. I might try i3 one of these days, but I haven't tried it yet. Totem, time to go to sleep. Have a good day. Have a good one. You too, man. Thank you for coming in and chatting. And welcome. All right. What is that at the bottom? Oh, all this stuff? So I'm using WesTerm. And so I can have multiple... it's got kind of a multiplexer built into it. And then I've got tmux here, right? And so this is actually... this tab right here is actually connected SSH to my work machine. So I can work on that, which I'm not going to pull up right now. In fact, I should probably close that off screen. Hold on. So I don't accidentally click it. Okay. So yeah, just it's kind of a nice way to allow me to I can SSH into my work machine and use still my desktop monitors and all that stuff for it. Because one of them is SSH'd to another machine, and I don't want its settings colliding with mine, right? So I want the ability to say, this is my local stuff, this is my work stuff, and I want that separation. And then in each one of those, I have a separate multiplexer there. So like this one, I've got, multiple things going on at a time, multiple projects, right? So this just makes it easier for me to switch between them locally versus, my remote machine. It's kind of a weird setup, but it works for me. Okay. Okay, so that all makes sense. I think this is going to work just fine. Use console on KDE, which has console profiles. Console's pretty nice. I don't know, though. I like WesTerm a lot better. It uses the GPU for one thing, and I like its configuration. Its configuration is pretty simple. It's just an easy text file to configure stuff. Really lightweight. I like it. It's fast. Console is a little bit heavier. I switched to it a while ago. I've tried a whole bunch of different terminal emulators, and this is the one that I like probably the best so far. I used Kitty for a while too, but the dev for that can be a little abrasive at times, and I'm not really a fan of that, so... Oh, right. This is going to have to pass through render data. I was wondering why that was bleating. Okay, so... I guess at... So where do we actually call our UI system render? We actually don't have this called from anywhere yet. So basically, wherever I call this from, I'm going to have to set up the... I'm going to have to set up the renderer, the render data from that point. And I don't actually have this hooked up yet, so I don't know where that's going to be. I might leave it up to the application to call that. Or it might actually be in this pass. Because this pass actually knows about the standard UI system. So that might actually make sense. Exxon47, thank you so much for the follow. I appreciate that. Trash can, see you later. Good night. Have a good one. ST is, yeah, I used ST as well. The only thing I didn't like about ST is having to constantly recompile it for changes. But yeah, ST is pretty nice. I've used that one before. Sometimes I like to be able to, you know, make configuration changes and then see it right away, and that's what WesTerm does. Not a huge fan of having to like recompile it whenever I want to make changes. All right, so I guess it does make sense for this to know about this. So I might actually come through here and like remove all this other stuff out of here in favor of what we're implementing, but we're not quite there yet. What can I do in terms of, so I guess UI pass. I'm debating whether to move this now or not. I think I'm going to. So when we are preparing the frames, right? We already have all of this data here, and the location of this won't move. In terms of like gathering, oh, you know what? The data gathering places where this should go. And then that could be loaded into the pass data, and then the pass can call. That's what I'm going to do. Okay. So our frame render graph basically just has all of these things configured right here. So this is our skybox pass, our scene pass, our editor pass, and our UI pass. And right now, this bit actually exists in the test bed, and I think I'm actually going to move it to the standard UI because we actually are we referencing the standard UI in here yet? I don't think we are, but I think it's more than safe to. Because we're not actually loading this as a plugin. And I think we might be linking this. So there's the standard UI lib. Yeah, we're linking with it already. And I think we also are including it. We are. So the testbed lib already knows about it. So let's do standard UI. And we're going to include standard UI system. Which eventually some of this stuff will need to be split out a little bit more from just that single header file, but for now I think I'm okay with it living there. And then this will essentially wind up moving here. So I want to take this guy and put it there. And then move, whoops, this one up here as well. Right. Just make sure this builds. Oh, right. Gotta clean first. Then build. Haven't updated my system in a long time, so 400 packages and I'm updating right now. Ooh. Are you on Arch? Actually, if you were on Arch, it probably would have broken. Although, I'm probably way behind on packages too, because I tend not to update like from the day before I stream till like the day after I stream. You are on Arch, by the way. Nice. Yeah, I tend to like only update once a week when I think about it. But if like now I'm streaming and I'll be streaming tomorrow, I'm not going to update until probably Friday, maybe. Because I do not want things to break. Okay. So the UI pass has moved. We don't really need to move anything other than that. But the UI pass kind of belongs there because it's going to become the standard UI pass. All of its data gathering is done by the application, which it should be anyway, so it doesn't need to know about any of that. I thought I had AXT data. There we go. So, where is our UI pass? Here it is. Okay, so the extended data is already dealing with the view matrix and the projection matrix, so I don't really need to worry about those. So I can actually get rid of those. Yeah, those are both renderables, render data. Those are both handled by the application, so I don't need those. I think all I need is the UI atlas and the renderables. Do execute, we want to be true. So here we're setting geometries, which is geometry render data. We're creating a D array for that. So I think instead of just having geometries here, we're actually going to reuse the standard UI renderable. We'll keep the geometries as well, but I think the standard UI renderable is going to be something we want to add. So let's see, extended data. So U32 renderable count. And then, actually, I don't even need to do that. I can just use a D array. So standard UI renderable, renderables, right? And I could just use the array that I gather to assign that to here. So, I guess actually let's do that below. Do I want to do below that? Yeah, I guess I can add it down here to the bottom. So let's say we have standard UI render data, and we're going to say SUI render data, zero that out, and then SUI render data renderables equals darray I'll do a create for now. Create, rather, with allocator. So we want the type, which is going to be standard UI renderable. And the allocator is going to be the address of pframe data. Let me move this up so you guys can see it. Allocator. Right, so we're going to use the frame allocator to do that. Take advantage of the speed there. And then SUI render data UI atlas. Where are we going to manage that? Call to SUI system to get this. We don't have that yet, but I'm thinking we'll just have a call to the system to actually return that for us. Let's see. Let me catch up on chat. Oh, pound include your standard UI system. You're surprised it didn't break that you're on Arch after all. Yeah. I mean, you know what though? Like, I haven't had Arch break that many times, surprisingly. Like, it's been a few times, but nothing really major that I couldn't fix. You just started programming and you have no clue what language to learn. I mean, I would definitely say C. Maybe I'm a little bit biased on that, but if you learn C, learning any other language will be relatively straightforward. So, I mean, C is a relatively simple language once you wrap your head around pointers, which I literally have a video that explains pointers in 60 seconds on my YouTube channel. So once you wrap your head around that and how it works, it's not too bad. Turbo Pascal. Oh my god, that brings back memories. Oh man, Turbo Pascal, I was programming that in middle school. Just malloc and use void pointer easy. Yeah. Void pointers for everything. Oh man, I remember Turbo Pascal. I remember writing like text-based games in that. Let Windows free for you. I mean, when you kill the application, any OS will, right? I mean, I know for a fact there's things in this engine I'm not killing when I shut down. It is what it is. You know what pointers are. I mean, if you know what pointers are, then that's like at least half the battle with C, then. If you understand that concept, you're way ahead of the game. And like I said, they're not complicated, but it trips up a lot of people. But if you understand pointers, then yeah, you're way ahead of the game, for sure. One cannot simply know pointers. Pointers are a way of life. This is true. This is why I get sad when I see smart pointers. They're just variables that store a memory address. Exactly. That's it. That's literally all they are. Okay. Where was I going with this? So we have, I guess we need to store this in the ext data. So that's on the UI pass. Oh yeah, we don't need to store the... Right. This is what we actually need, not this. Right, we want actually that whole structure there. So I can say ext data SUI render data, right? And then there we go. So that object lives on the UI pass data. We stand a new one of these up every frame, which comes from our frame allocator, which is a linear allocator, so that's going to be fast. And then we populate it by calling standard UI system render. Oh, wait a minute, though. Do we have... Can we do that? Oops. I want one more. Yeah, because this is the function that isn't hooked to anything right now. So we want standard UI system render. We do have to grab the state from that for that, which is kind of annoying. State manager. Oh, really? We don't have the... Oh. Systems manager. Get state. Do we not have an enumeration for this yet? I thought we did. Have we even registered this yet? I thought we had. Systems manager register. There we go. Case system type standard UI extension. That's what it was. This is what I need. Yoink. And then we need is it render frame? No, it was up here. So for the state, I need that. We're going to call this SUI state. Why did you do that? Okay. Why is it saying... undeclared variable? I mean... Oh. Because I declared it there. Right. Okay. So... let's take this. And we're going to put this right here. That way we can use it elsewhere. We really do need to fix this though. But that should at least allow us to move on. Hercules, thank you so much for the follow. I appreciate it. Welcome. Let's see. X Rice Bowl. First time chat. Welcome. I started a project in Rust just to give it a fair go. Starting to regret that now. Yeah, I did the same thing a while ago. I don't like compilers telling me how to format my code, first off. And I don't like it yelling at me when I try to use memory the way I want to use it. Is Arch better or worse than Java and C#? Oh, Rust. Okay, I was about to be really confused for a second. I was like, wait, what? Rust is great until you need mutable state. Yep, exactly. Then every type is riddled with mute. Yeah, exactly. That's so annoying that you have to like declare things mutable. Is it better than Java or C#? Yeah, I agree with Jake. It depends. Java and C# are way easier to learn than Rust, for sure. Rust is great if you like academic type flexing. That is a great description. Hercules, happy to be here. Thank you for following and welcome. I would say learn C# for game dev, but then Unity went downhill, and yeah, I don't trust that crap anymore. You must love TypeScript then. TypeScript is pretty cool. I mean, I've used it on projects, even on my YouTube channel. I wrote a small engine, if you can call it that, in TypeScript. It's certainly better than using raw JavaScript, I think. State machines are the best to implement in Rust, i.e. anything networking related. I can, yeah. Learn OCaml. You know, a lot of people talk about OCaml. Maybe one of these days I'll just have to pick it up just to see what it's about, because I don't know anything about it. Okay, now what about C++? What about C++? OCaml is much better and won't translate to most other languages. Yeah. Yeah, I've seen Tej use OCaml before on his stream, and yeah. The syntax is interesting. Is C++ goodish? I mean, it's pretty industry standard for game development, that's for sure. I would say learn both C and C++ if you're going to go that route, so you know the differences between them, because there are many differences. Just because, and I would say also, just because you know C++ does not mean you know C. A lot of people make that assumption, and it's definitely not true, because there are a lot of differences between the two that don't necessarily translate between the two of them. OCaml is the recursion, the programming language. So it's what PHP tried to do with its name, basically. That's what I'm hearing. Bro, just pick one, but not Python, please. Yeah, I mean, there's worse things than Python out there, but you know, there's also that. Hold on. There's always this language. Robotic head, exactly. Yep. That's exactly what I was pulling up. Yeah, there's always this one. Try writing a game in this. Let's see. So we have render root. So I guess how do I determine what is the root, though? Do we know what is the root? Maybe I should make this so that if you don't provide a root, that it just kind of decides one. We don't actually have a root control, do we? We do not. So that's a thing. And I suppose the root control could be something that we just don't expose. Right? Like the root control could never be, it's not ever drawn, it's not ever updated, it's not ever active or inactive, it's just there. Have I seen JSF? No, I didn't know that was the thing. I'm afraid to Google this. Write any JavaScript with 6 characters. Okay. This is actually kind of funny, so I'm going to bring it up. Does not depend on a browser, so you can even run it on Node.js. Okay, so yeah, it's kind of the same thing then. Ish. Oof. Oof. Yeah. Time to write a game engine in that. The thing is that it's valid JavaScript. Yep. Yeah, I mean, JavaScript, you know, has its place. You know, it's just, it was never meant to do what it's being used to do. And it just kind of kept getting piled on. Okay, so we can do the address of ext data SUI render data. And that does return a Boolean. So if it fails, we're going to bleat about it. Failed to render. I'm not going to crash do that or abort the render, though. I think we'll just move on. JS has grown a lot from the day it was implemented. That's the thing, like, any language that has been around as long as that has is going to have growing pains and stuff that's terrible. I mean, look at C++. C++ is a mess. Especially modern C++. Like, all of the templating and namespacing and all the extra syntactic sugar crap that's just put on top of it. Yeah, it's crazy. Ads. So it looks like this one's like a 2-minute ad break, so there's still about a minute left. About 20 seconds left on ads. And we're back. Namespaces are cool, and yeah, I basically just responded to that in chat saying, yeah, namespaces are cool until there's 5 of them nested. STL got a bit off track. Yeah, that's true. C is old and not that bad. I fully agree, and that's one of the reasons I like C so much. It's been largely unaffected by all of the garbage that's gone into C++. Tammon, I like your example there of a namespace, 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 namespace. Get used to it since you're going to be using Direct 3D 12. I was going to say they have a C API. I don't have to use the C++ API. Have I heard of Zig? Yes, I have. I've not used it, though. How would you suggest that I learn C? I mean, I learned it out of a book. Literally this guy here. Would I say it's the best one? It's probably a little dated, so maybe not. But I mean, C is not really updated all that often. So this was a pretty good book. This was Teach Yourself C in 24 hours, and that's like 24, I guess, cumulative hours. So like not in a day, right? But so I would go that way. But there's also a lot of free resources out there on how to learn C. I've started putting together some videos on my channel, but I haven't actually updated it in a long time. So I don't really have a complete course there yet, but eventually I will. Direct 3D 12 C API verbosity is off the charts. Is it any worse than Vulkan? I haven't actually looked at it yet. Full disclosure. Not in detail, anyway. Can't imagine it'd be too much worse than Vulkan, but... Okay, so the only thing we have to figure out is this root issue. And I think I am going to go ahead and right in the standard UI state, I'm going to put a SUI control root. And when we initialize, let's see. I'm going to say standard or SUI base control create. I'm going to call it something like this, root, right? And we're going to pass it the address of typed state root. Right? And then when we go to render, right here, if we don't pass root, then root is the address of we don't have our type state. Type state root. Right? And that's how we get around that. So here we just pass root as nothing. and then I'll say start at the root and continue on. And that's actually all we're going to have to do to get that renderables list, which is pretty sweet. And then when the UI view goes to process this, it'll have everything it needs. So UI pass rather, not UI view. Okay. So on execute, it looks like we do, so geometries, apply globals, bind the viewport. This is actually what we're actually gonna need to copy this. So let's grab that. Oh, you know what? We're not even gonna be able to do that. We just need this. Draw geometries, draw bitmap text. Okay. Renderables. So the first thing we'll do is use the SUI shader. Standard UI, UI shader. So we use that. Apply globals. Right, and so this is where we're going to want to apply some of these things, right? So let's see, where's a good example of, I guess I can just go, why would I want the same thing twice? Really? Okay. So basically what I want is these two guys. Yoink. So instead of utilizing the material system, we don't have this macro, so we can do away with that. This is going to be internal data, SUI locations, internal data, SUI locations, and projection. We can get this from our ext data, I think. Or was it the past data? Might have been the past data. Oh, it's going to be self past data, I think. Past data. Projection matrix. Okay. Just want the address of that. Yes, it does. Okay. All right, so self past data. Whoops, why'd I put a $sign there? What a dingus. Self past data view matrix. Okay, so that's our globals. And then renderable count equals the array length. ext data renderables, right? So we get the length of that array. U32 I equals 0, I is less than renderable count plus I. And then we have, I think I'm just going to grab a convenience pointer to that. Standard UI renderable equals address of ext data renderables sub I. And then this is actually where we can do the geometry draw call too, right? So we can say, we can draw it down here, renderer, geometry, draw, and that's going to be renderable, render data, and we're going to want the address of that, right? So we can draw that, and then apply locals. We'll do instance first, actually. Instance, which actually, I'm not even sure we're going to have any instance ones because the texture map should probably be global. RC, first time chat, welcome. MVP underscore, somewhat related. I feel a lot of C devs dump on OOP, then re-implement anyways, but enforced hopefully by convention instead of by typing. Yeah, I mean, I think OOP has its place. I just don't think it's everywhere, right? So, I think it's vastly overused, right? So there's some concepts that I kind of touch on from it here, but I don't really use it all that much here. But parts and pieces of it, certainly. So hello and welcome, by the way. Let's see. Wow, Taman, that's a actual function call? Like an actual name of it? Wow, okay, that's... See, and APIs like that make me glad that I have auto-completion, right? Because ain't nobody got time to be typing all of that every single time. No, I know you weren't talking about me. Yeah, no. But there are a lot of people out there who are like super anti-OOP and slam it. And while I don't agree with a lot of its use, I don't, everything does have its use, right? It does have its place. Game engines, I don't know if that's a place it should be used, but certainly in like business software and stuff, absolutely. So just outright say that it shouldn't be used anywhere ever is blatantly false. There are reasons to use it and there are reasons to not use it. It's always just about using the right tool for the right job. Objects are useful, it can be. Like I said, I don't use a lot of that here, but there are instances like this UI system is kind of touching some of it a little bit. Okay, so, I seem to recall when we apply globals that we had to do, yeah, we do have to do a call to apply the global. So we need that here. Again, we don't have that macro. And I think this is indicates if shader internals need to be updated or just to be bound. So this is going to be the first and only time that we're going to call this, so we're going to say true on that. Sync the frame number. That is probably another important thing that we should do. So this is going to be let's see. Do we have it's internal data. Internal data SUI shader. All right, we'll go ahead and sync that up. And then for instance, we have to bind an instance. So that's here. Oh. But we don't have an instance ID. So with materials, we just kind of have an instance ID, right? But each one of these objects is going to have its own potential property for color, right? So each one of these renderables needs to have its own instance. Which means whenever we load that up, we're actually going to have to store that somewhere. Boo. Okay. Do you have some cool type erasure for uniforms, by the way? I'm struggling a bit with supporting arbitrary object materials. Not yet. I actually have another branch where I've been looking into shader reflection using the libraries that come with Vulkan to see if I can actually, like when I read the actual shader file, to pull the actual uniforms out of that and build my uniform information off of that. Because right now what I have is these shader config files, which look a little something like this, right? So I give a name, the render pass is kind of irrelevant at this point, and then the stages, right? So vertex and fragment, and then the stage files which line up with that. So we have the vertex GLSL shader file and the fragment GLSL file. Whether or not it uses depth test and write, and then we have the attribute set up here, so it's type and then its name, and uniforms here with a scope. So we have scope is basically like how often it gets updated. So global is basically updated once a frame. Instance is once per, typically like once per material instance. So like if you have a wood material that's on several objects, you would apply those properties at the instance level. And then local is basically model transform, right? And so we have uniforms basically have a type, a scope, and then a name. And so that's kind of how we're doing it. And then for custom types, I have the ability to put in struct and then how big the structure is in bytes. And then we're able to just kind of use that as is. So I hope that makes sense. Since you will be supporting Direct3D 12, are you going to switch GLSL to HLSL? I'm probably going to come up with a way to funnel them both. Like convert GLSL to HLSL and then compile that. Since DXC can compile to SPIR-V, you don't need to have shader duplicates. Right, yeah, so I'm going to find a way, like that might be the way that I do it. Is just using, the SPIR-V compilation that I'm already doing in the engine right now, and then just feed that over to DirectX if that works the way that I think it's going to. But if it doesn't, then I'll have some sort of process that'll pick up this file and translate it to what I need it to. Or not this file, but the actual GLSL files. Having all your shaders as SPIR-V is good, as SPIR-V to HLSL and SPIR-V to MSL is easy, yeah. So like I said, I might leverage what I've already done sort of in the Vulkan backend for loading those dynamically. I might just leverage that. Okay, so this is something I hadn't thought about. So I'm going to need instance resources for each renderable that actually needs it. So that's another property I have to kind of keep track of. And along with that is also going to have to be a frame number for that as well. So I'll have to do that as well. Okay. Actually, let me go to so I guess I could actually put it in here. U32 instance ID and U64 frame number. Oh, and I'm also going to need U64 draw index. Okay, so... And then if I don't use these, I could just ignore them or set them to invalid ID or something. Okay, so... internal ID... Right. So I guess when I load, this guy, I probably also need to acquire instance resources. Shoot from the shader. I need a shader reference there. Which, I guess it is the UI system, so... shader system... get... oops, shader s equals this. Then I could just do this. Texture map count for now is going to be... oh, I need 1 for that, actually. This was something else I forgot to actually set up as well. This one is going to be the address of type data. Oh, I can't put it with the render data, can I? That's got to be the internal data that I get that from, and then the render data's got to take a copy of it. So... Extreme Digital Tech, thank you so much for the follow. I appreciate it. OpenGL makes it pretty easy to query a compiler program object for uniforms, etc. Yeah, Vulkan actually has something like that too. And as you can imagine, it's a lot more verbose. I actually do have something working, but getting things like recursive structures and extracting that kind of data has been a little tricky. What type does shader system uniform set by index take as a second argument? Do you use C generics for that? No, so it's just a void pointer, and then I could just pass the address of whatever data it is that I'm funneling through there. Compiled program. Yeah, so it's I just use void pointers there. Yeah. Because I know what the type of the interface or the type of the uniform is, I know how many bytes to copy. So okay, so I needed U32 instance ID, a U64 frame number, and a U64 draw index. No, I think that was a U8 draw index. Right. Which actually this should be a U8. And I'm actually going to do something a little bit different here. These are going to be pointers, because I need to update these from over here. And by doing it this way, I can actually update it going backwards. So, okay. All right, so this is going to be dereference that. And then standard UI system. So when we do loading, oh, texture maps or something I haven't figured out yet, but okay. So type data, instance ID, okay, and then texture map. So this is literally just going to take a copy of it, right? So texture map pointer. Okay, so here we are going through the material maps. I didn't even think about that. I have to set up a texture map for that. So the sampler knows how to be created. Do I want to create another one every single time, or just kind of reuse the same one? I think I can just reuse the same one. Okay. So let's go with texture map array. Actually, texture map pointer array of 1. And we'll call this maps. We'll set this equal to the address of typed data. Actually, no, this is going to wind up being the state, I think. So address of typed state what did I call that? UI Atlas, I think it was. Where did I have that? Oh, that was in the top of that other structure, wasn't it? That's here. So that is a pointer as well, which is actually good. So I can put that here as well, except have it not be a pointer. Typed states. I want the system state. I don't think I have that here. No. So I'm going to have to use... I don't think I have anything here that's actually getting that for me. Okay. Here. So the state is going to be... Don't have it included. Where is... Oops, not editor. Engine. Oh, did I put it under core? What a dingus. All right, systems manager. Get state. And I happen to know it's 128. Which is bad. Need standard way to get extension types. Okay. It'll work for now, though. All right, so we get the type state. You know what? This line should be moved up here. All right. We get the type state texture map. We hook this up to type state UI Atlas. Not sure why that's there. And then we have shader system get, which actually pretty sure we don't have that in here. Systems, shader, system. And it looks like my auto-completion has died. Right along with my brain for tonight. Okay. So now we should be able to just do... maps. Okay. So, acquire instance resources for this control. Okay, so we've got the system resources that we need. That gives us our instance ID that we need to be able to draw it, bind it, and all that stuff. In here, we need to copy over a couple things to our renderable. Oh, my auto completion is back. Okay. So the renderable instance ID is equal to type data instance ID renderable. It's not. Wow, it undid that whole thing. Rude. And this needs to be the address of. Okay. Renderable frame number is equal to the address of typed data frame number. Renderable draw index is equal to the address of type data draw index. Right? And what that'll allow is over on the UI pass side, we can do this. We can synchronize, sync the frame number. So we can say renderable renderable frame number, and we want to dereference that, is going to be equal to p frame data frame number, render frame number, dereferenced renderable draw index is equal to p frame data draw index, and renderable, actually I think that might have been n. Yeah, because we're already using the instance ID, okay? So because these are pointers, these updates will flow all the way back to our internal objects where we need them. Okay, so we bind the instance. And then we go to material system. Back to apply instance. And we're essentially going to I'm going to do these two things. We'll fix those in a second. Don't need any of that. All we need is this. Okay. All right, so we bind the instance. Right. Needs update. Needs update. We pass that in. I think we use frame number to determine that. So B8 needs update equals renderable frame number equals p frame data frame number and dereference renderable draw index equals p frame data draw index. Actually, those should be not equal checks. All right. So that's the needs updates. This is going to be ext data SUI locations. Wait, wasn't it? No, it's internal data. There we go. Okay. Internal data SUI locations diffuse map. What is at the end here that it's bleating about? So properties. So actually for this, all we want to do is we want to say renderable. Did we not include that? No, I think that's at the top level actually. It's ext data. Render data, UI atlas. There we go. Okay. And then for the properties, we actually need to fill out a struct for that. So we're actually, in this case, we can literally just use the vector4. Because it's a struct only with a vector4 in it. I'm going to cheat and do that. Okay. So this is going to be renderable diffuse color. And we're going to take the address of that. I'm going to put a note here. Expand this to a structure if more data is needed. Okay. So there's that. So we have instance. And last but not least, renderer. Or no, I think it's shader system apply local. Was it? What was it again? My brain is basically fried for tonight, I think. I'm actually over time, so I'm going to have to wrap up here in a minute. Let's see. Does Vulkan provide a function that also takes a void pointer? That would be handy. OpenGL requires the exact correct function call. Yeah, so Vulkan doesn't have anything like, you know, set uniform 3F or whatever. Doesn't have anything like that. They're descriptors that you have to update basically as a whole. So it's basically a block of memory that you apply. So these abstractions that I have here with applying uniforms, that doesn't exist in Vulkan. Or instead of and on pass 233. Maybe. Needs updates. You're right. Thank you for that. Should have been an or. You're right. Yeah, you just push bytes. Exactly. Ned Stark, thank you so much for the follow. Appreciate it. Is the stream going to midnight? Definitely not. No. I'm actually going to be wrapping up here in a couple minutes. I just want to get this basically right here. I just want to get the model matrix in there, and then apply local. So this is going to be, what is it? Internal data, SUI locations model. And this is going to be renderable render data model. And I think we need the address of that. All right. And that is all there should be to actually drawing that. So in the next stream, we'll actually try creating one of those, setting the size and drawing it and seeing where we wind up with all that. Made a lot of changes tonight, definitely. So work in progress. Added panels. Moved UI pass to SUI lib. Oops. SUI lib. And began rendering logic. Once we get most of this system level stuff, scaffolding out of the way, creating the actual extra controls and stuff won't take as long. All right, let's go ahead and push this. All right, so that's available on the standard UI branch for you guys to see. And that is going to do it for the stream tonight. Thank you guys so much for joining me. I'm going to drop all my social link spam in the chat right now, just so you guys can catch up with me and follow me on all my social places to see any updates that I might have outside of here. And so, you know, there's things in there like my Twitter, my YouTube channel, which all of these are archived. All of these streams are archived over there. Also the Kohi website itself, as well as some other things like the Patreon link and that kind of thing too. And so, yeah, I encourage you guys, if you haven't already, follow me on here on Twitch. Go ahead and check out my YouTube channel and subscribe over there, because I will be posting updates that are done sort of outside of the Twitch universe or the live streaming and whatnot. I post things there outside of that as well. So anyways, let me quickly see if there is somebody on I can raid. And I'm super tired tonight, so I think I'm going to wind up going with my tried and true favorite, which is Ferret Software. So this is basically a ferret rescue run by Pirate Software, who's another game developer here on Twitch. And he's basically rescued 17 ferrets, I think, at this point, from around the state of Washington, that are used for like medical testing and things like that, and also ones that were neglect and abuse cases and things like that. And he gives them a good home. And the most important bit is all of the ad revenue from this channel actually pays for the care that those ferrets receive. So it pays for their medical bills, their food, and believe it or not, ferrets are very expensive to take care of properly. So I think this is a really good cause, and I'm happy to contribute to it whenever I can. So that is what we're going to do tonight. We're going to raid that, and I just encourage you guys to leave the stream up if you can. And it's a good cause to support. So thank you guys so much for following along, and I will see you guys on the next stream. See ya.